everyone. Thanks for joining me here. It's Saturday, of course. We all are supposed to be at Dutchess, but you're still here. I think the topic that we're going to discuss is going to be quite useful and interesting, especially in the wake of the previous speakers' presentation. We'll speak about people and human errors in the first place, and then we'll speak about people in a different way, like no one else has said, and like we normally speak about other assets that we take into account, with which we work in security processes. I would like to say a few words. I'm Sergey Valdokhin, and I work with the anti-phishing team. We make products that address the human error issues, which previously, just for a few years, I worked trying to manage the security in a sizable company, in a big company. I mention this because you will know that it's important, and it's regarding the concept that we developed with my colleagues. Who's ever read Alexei Lukatsky's blog? You may be familiar with Alexei Lukatsky. If you read it and read it carefully, you may remember the post where he shared the impressions from different security products use. So this satisfaction level in cybersecurity is worst through the IT assets management. But IT assets management is one of the fundamental processes, and the order in that starts from the order of the IT processes. If there is something wrong about them, the satisfaction level will be low, and there will be less order in place, so to speak. In the perfect environment, we use processes with best practices. We have ITIL, ITSM, different solutions, and in the perfect world, this is what looks like. This is how it works. But here is the real world. Here's the real world. And the company where I handled the security and where everything was ultimately great, it became great due to those proper processes, but it was not the world of pink ponies, as we said here earlier. Those were very sluggish and very slow systems, and I'm very happy that there were people here, sitting here in this room, that helped us implement them, that there were real systems that maintained those processes. They were not perfect, but they did work, and it's important that those systems and processes had asset management, and those assets could be seen in the visual graph, which is a very good thing. So my experience tells me that it's indeed the foundation. It was the foundation for very productive results and nice security. But regardless of those processes and regardless of that asset management, me and my colleagues for risk management, risk assessment, we had to use some kind of register. Here is the name of the assets, which is replaced here, but it was all about how we handled that in practice. Is the registry of assets, and it was very important. You can see all of the names that are familiar, and you may have something similar. Maybe you don't have raw materials, but all the rest looks very similar. So what did we do about it? We can do quite a lot of things that we manage. We can describe the threat model, we can evaluate the risks, we can describe the unacceptable scenarios. And for instance, here is the access to the server of the database, a theft of a notebook, the hack of a supplier through supply chain attacks. So the target systems are also on the screen. Those things work when you have proper asset management. And many other things allow you to paint such nice infection flows and other scenarios of an attack deployment. By the way, do you like it? Please raise your hands. It looks real nice. It looks real neat. Lots of details, nice order. It's very nice to know how PowerShell launches this, but there is one small problem with this flow. There is a part missing from it. And what part is missing, by the way? Yes, indeed. It's missing a very insignificant part, like a person who can either do something, like, for example, open the mail and launch this LLK, or not launch this. This, it's what it's all depending on. Like Andrei mentioned in the previous presentation, this whole playbook really depends on that. If a person opens this, there will be an incident. If it doesn't, no incident. Or even if it's reported, it will protect all the other people. So here's before and here's after. Insignificant difference, but which hides 90% of the effort of the people that can be saved and used proactively just to prevent, really prevent such incidents from occurring and have a stronger protection. So when we were prepared, when we were preparing for such a presentation here, maybe we thought it was our cognitive perception. Maybe it's just from our experience. So we just checked the latest breaches of the data investigation reports in 2022, and seems like that the human error is not just a thing, it's the main factor, it's the main driver, which leads to 82% of the incidents. So if those human errors were a company, they would just take the absolute monopoly worldwide. So it would be very strange not to address this, and it proves to be a real big problem. You all know about MyTree attack, and you all know about initial access attacks. Initial access was analyzed by us, and to our surprise, we figured out that 9 out of 9 methods involve human. They involve people, human participation. 90%, or I mean 100%. The anti-phishing index accounts for 50% when someone is doing something and this technique starts working. So it's 9 out of 10. Obviously, I'm acting here like a Captain Obvious. Have not discovered anything new. So somebody would say, Sergey, it's just very common knowledge. We've all read Mitnick. We all have experience about that. So I'm risking to sound like Captain Obvious, but it proves to be a very significant problem, and somehow it's not resolved. Why? Maybe because all those people who work in cybersecurity have some mental restrictions, and these restrictions in extreme cases turn us into cybersecurity police force. We would ideally be in the green zone, but that's ideally. And where's reality? Between the ideal situation and the real world, there is a difference. And you may be aware of a situation. I wouldn't really want that we'd limit ourselves with simple advice. Our limitations and our background and our processes are such that we know how to work, how to handle the technology. We work with the determined assets that are clear and clean. The assets are clear and clean, and the threats as well. But human behavior is something uncertain, and we still have not been able to learn how to handle that. There may be another story. It's the linguistic relativity hypothesis. Basically, it's the language that identifies thinking. We cannot identify the terms, we cannot even think with the terms that do not exist in our language. We don't know the word, and therefore we cannot think about it. We do not take this into our work. That's another philosophical concept, but how does it relate to our topic? Very simply, if we do not identify an employee more clearly, if we do not identify their activities, if we do not speak about the human error in metrics and KPIs, in indicators, we cannot measure it, we cannot do anything about it, we cannot handle it. It's just like a word that does not exist. Of course, there is some threat in Stack. It's a good resource, it has techniques, it has methods, and protection measures that are 100% about the people. Seems like it's all defined, but now let's check the real threat, a real threat, an attack which is 100% related to people. When they deploy malware through email, if you don't have an exploit on the mail server, you cannot deploy anything malicious without the involvement of a human being. So maybe these components and objects that are affected have some influence, but all these letters actually stand for different things. They stand for email, but where does a human being belong? What particular actions by the people, which kind of people will do that? Most certainly, so that it will be deployed. If it did belong to the components, I would have pointed a mouse there and it reads operating system, a web client, a web server, a mail server, and it does not include any people. We've collected something else here, how these mental restrictions affect the situation. This is how the incident is described by common definitions. This is how it's explained in other rooms here, and this is how we talk about it here. So this virus infection encrypted dozens of thousands of workstations. But in actual fact, what happened? An accountant opened an email and launched the file that looked like an invoice. We never mention that because we don't use these terms in our language. Example number one, an account was compromised and there was a possible access to the internal web portal, and we speak about it. But what indeed happened? Here's the question. A manager, a sales manager, received a message in the messenger and followed the link and put the password twice. Such a great thing he did. But we never speak about such things in simple words. I may have a couple of other examples, but mainly you understand my idea. So basically, due to our limitations, we don't have this available. A glass ceiling separates us, and we cannot speak this before. Another example, which relates to more complicated things. Those people who read the news, you can see it on the news every once in a while, host Elasticsearch with the default authentication policy, the default IP, no policies, restriction policies, so the user gets access to personal data. You've read about the Elastic, right? But what indeed happened? What indeed happened? What kind of person was there for the first week? An urgent call. Seems like everything worked, and he said, okay, I managed that, but read what followed. Somebody said that especially those guys in the big tent would say, normally there are some technical attacks, for example, the web attacks. So what does really depend on a human being? 80% of the successful attacks to the web, they are not web attacks. They are attacks on people. Because, again, check this chart. In 80% of the cases, a web app uses credentials, and how these credentials are made. So this is how this is made. SQL injections, CSRFs, indoors account for 20%, but there may be a brute force added to it, so it's a little bit less than 20. So here is an example. It seems like nothing depends on a human being. Hackers scan our systems on a regular basis. They can find non-patched servers, and the admins leave these business-critical servers naked instead of putting them behind the VPN, and they never patched them, and they complained about evil hackers scanning their systems then. So those who don't really want, they look for explanation, and those who really want to find out, they look for the cause. What would we say in the summary? The expenses on IT security, cybersecurity grow, and the number of incidents grows even faster. And you know why? Here's the reply, here's the answer, and it's shown here on the bar chart on the right-hand side. We know what this money goes to. That goes to people. That's the least category. It accounts for less than 3%, and our experience proves that it's less than 1%. What are we supposed to do about it, and what exactly can we offer to you? So what are you supposed to do just on Monday? Me personally, have a Unix administration in the background, and my colleagues as well. I don't know much about the modern technology admin-wise, but I've heard something, I've seen something, and I've seen this. And what am I showing to you, by the way? Do you know? Can you say what I'm showing? Can you name it? I think you may recognize it from here. This is a deployment file, which is used to describe the configuration of Kuber. And here's another example. What does this stand for? Any ideas? Do you have an idea? Excellent. This is indeed a description of the Terraform. Why do we mention Kuber? Why do we mention Terraform? If you've ever tried to administer infrastructure, if you've ever tried to do that manually, you may be aware that if the number of servers and services grow, and the number of systems do grow, it becomes very difficult with this undetermined environment to manage something. So when we end with the situation when people learn how to handle this problem, and this approach works, and it's called everything as code. Everything as code is an approach to software development and DevOps that uses code to define and manage IT resources. All of the elements of the infrastructure are determined as code, and thanks to Kubernetes and Terraform and Ansible, which we mentioned here previously on this stage, all these things described as a code become manageable, and you can handle and manage thousands of variations of code and different systems. It all happens because we know the description that it is described what is required there. Even if the system is heterogeneous, it becomes manageable. Basically, this is the idea. Every element of the process of the software development is described as a code. That's the idea. So that's applicable by our colleagues already. If you have the developers, the writers in your team, please join them and take a look how they work with the documentation as a code, which is stipulated in a very simple language, and it's shown in the way of the beautiful schemes. Governance as a code. I do recommend you watch this presentation by our colleague from Sber. So it's a declarative language, again, that describes the requirements for automation in a certain infrastructure. Can we really apply this type of approach if we speak about people? It's a good question, first and foremost, but can we really do that? Well, first of all, people are not just any people, but people, I guess, are the most important participants in the software development, and in 80% of the cases, on people's reactions, we'll see whether we'll have some problems or not. So we may set the question like this: can we define people as assets that we can work with just like we work with technology, and make them a determined environment, make people a determined environment? If yes, then the infrastructure as a code would be making possible to describe it as services and components. But of course, then we'll be able to say that the deployment of people in an organization can also be described with words like motivation and capabilities and possibilities, access and skills. So these two categories are important. Why are these two categories? Because we have this model which is very, very simple. And I would like to show you this model that identifies the behavior model. It's defined by motivation and ability, with a low motivation, but if it's easy, this person can do it. If the person's motivation is low and it's very difficult to do, lower left corner, you are highly unlikely to get the result. If we understand the motivation of a person, if we understand the capabilities and ability of a person, we can create and connect it to the actions that the person is likely to take and may lead or not lead to an incident. How do we implement this concept, and what can you actually use on your first day at work if you learn this? We've implemented this structure which we entitled People CMDB. Just like, CMDB in the IT assets. We speak about people here, but before we start speaking about people, we relate IT security, we relate cybersecurity to business. It's critical to describe this. Different people in different roles may do different tasks, and they can do different things depending on a situation and processes. So we just need to connect people, their features and parameters to the actions that they might take. Of course, I will explain this one by one. Actually, the problem is real simple. The people who are the weak link here may really become a very strong and reliable cyber asset, depending on how you call them. What's inside this CMDB? That's our open source project. You can use this by downloading the repository from GitHub, filling it up with data that you consider relevant. We identify the business goals. For example, the contractors get their payment, and the clients work with a certain system, and everything works really well. But what can actually go wrong? For the first goal, some payments may be frozen because of the violation of the payment process. So that's an inevitable thing, as we call this at this conference. And here we are moving to the detail, which is very important. Event number one actually occurs and may occur just because this person infected the system with the ransomware. Specific roles are added here, people in the roles that may actually cause such an action. We add a structure which describes dangerous and safe actions. Dangerous would be the ones that lead to that, and safe actions are the most difficult things. What do we really need from a person? What is the person supposed to do right? So that we will avoid these incidents from occurring in the future. Another example, which is related to the non-productive event, if this app has a public vulnerability in the outer library, so who can lead us to that event? So there would be different roles. It's not an accountant's role, it's the developer's role related event. What would be the dangerous activities? How could that happen specifically? First of all, it could have been an unsafe action like opening of an unknown file, or with the developer case, they would connect a vulnerable library. Where would they connect this library from? From the fragment of the code in the Stack Overflow, or alternatively, they would just fix the version 2 years ago and not update the version. Those who know about the development can prove that that's not sci-fi that I'm talking about, it's true. Important actions have to be taken here. What would they be like? First of all, check and verify whether the connected libraries act and do their job. It's an obvious thing, but it may either happen or not happen. The question is why. We are answering this question with a more difficult structure, which looks difficult, but you can easily learn it. A person has certain motivation, like he can convince people, has certain knowledge and skills and certain tools without which they would not be able to do that. You can do almost everything, but there is some knowledge, there are some skills, like elementary, looking for proper functions should exist. And then a safe action from the developer. It's needed that the developer will choose safe dependencies. So in the first place, they would have to make sure that there may something that can go wrong. There are some safer dependencies and unsafer ones. And they should believe that their own people make a better code, and high quality documentation proves that it's safety the best way. You need to know how to select a proper library, and you need to be able to tell a good maintainer from a bad maintainer. And here we add another set of tools and services and technologies that are needed. Speaking in terms of other roles, like accountants' roles, the actions may be real simple, like reporting about an attack. But in order to make sure an accountant reports an attack, they should also be convinced that the IT assets are important and hackers may attack me in that way. The accountant is supposed to know about that. They need to be able to tell a malware from a legitimate file. And as a technology, there should be a certain plugin used, for example, to report the attack. It's a simple way, but if we do not describe this in a simple way, if we don't take into account this motivation, the skills that people have, sometimes it can lead to very poor results. We can describe the roles, of course, here, and we need to set the expectations motivation-wise, and we just use this criteria, which we call protection level. How safely this person would act, in other words, knowing all that that was explained to him or her, having all the skills in place. We connect it to the roles, and we add another field, which is entitled real motivation. Real motivation, we not just declare it, we measure it by the results of the training process. Would you please note the priority field, which systems this person has access to, whether they would take a critical position or not, and how it may help us evaluate the risks and threats related to this person's job title. How do we move this person from the low protection level to a higher protection level? Are we supposed to train people? Yes, we are. But the most typical questions the companies have, and our customers and those who just think about it, what are we supposed to teach people, and what kind of people are we supposed to teach? For example, this course about the work with dependencies and the code, the first half of it, the knowledge and skills that we saw that are required to the person must be included in the course. And this knowledge should be conveyed. The same applies to working with emails, the same applies to working with yet another object, which is called emitted attacks. Training courses are good, but training courses give knowledge. When we speak about learning how to drive, you can learn how to drive in theory, but you cannot drive without skills. Developing your skills is a whole different story, and setting the skills comes from experience. And for an accountant, this experience comes from receiving such emails in the background. These structures should not be sitting still. They should be made alive, and they should be connected within the processes and the company, like access management, for example. We have created something similar to DSL language, which is quite clear, which we may read like we read a normal text, and that defines the rules and algorithms, how we can connect people with access policies. For example, what are we supposed to check access-wise? What are we supposed to check with the access, and how would we defend everything? And would you please take a look at this example? That's how we integrate this with Service Desk. We need this because the InfoSec person says, please store the passwords in password managers. Don't store it elsewhere. Please provide them a corporate password manager. If you don't have this password manager installed, they will do whatever they like, but keep the passwords in the corporate password manager. Scenario number 2. That's what Andrei mentioned previously. You may not have noticed that because it was not mentioned there, but we need that. For all of the incidents, we check and verify the level of protection of a person, and if it does not meet the requirements of their role, this person needs to be sent to a training, or we may imitate an attack according to the security policy rules. And that's what the people shared with us previously. It's very important to pump up the motivation and conduct meetings with a person, explaining to a person what exactly has happened and why it's not welcome and what is supposed to be done in this situation. The protection level may prioritize hundreds and hundreds of requests that your 33 analysts work with, or you may have 3 of them, doesn't really matter. These people as code and DevSecOps are important. The quality gates and reports that we receive may be just a dead weight that you do not know what to do with. And you may send it to 3H, to those people whose protection level, whose skills, in accordance with the requirements, in accordance with the vulnerabilities found, are quite high. So these people can be given the bypass rights to bypass the quality gates. If you're quite certain about their level of expertise, it will just take the burden off the shoulders of your team, and the literate, advanced people will do this 3H in a much better way than a certain architect who saw the code sometime back in the day in the university. It's unlikely that someone else from the cybersecurity team can tackle that as well as the cybersecurity people. Here is a link. Here is a link to the materials that I spoke about, and this particular code is, of course, a pseudo code, is a fake code. This just shows to you what you could do just next Monday. What are your people? What roles do they take? What would you like to achieve from them in terms of their protection, in terms of their motivation? If you do not understand their business goals, maybe you don't really know their business goals, but ask them if they know their business goals. Ask them if they know the dangerous events, connect them to the safe events and their course of action. Identify the things that you already have and what you are lacking in order to make sure that the people have already the necessary skills. And people need to be convinced about that. Those people who really wouldn't want to know how to find the reason, and those who would really like to do it, they find the way. And don't forget to integrate it safely with the processes that you already have, and make sure that these processes are connected with people. People as code, this is the concept about people. Don't leave people as a weak link, make them a strong link and make them active participants of the cybersecurity process. I'm done, you guys, and I hope you have a few questions.
Sergey, большое спасибо, крутой доклад.
Thank you for your interesting presentation, Sergey. Could you please clarify if the person is motivated to make errors, this bad event really happens? Good question. We had a structure which we entitled Safe Actions, but there were such structures that we entitled Unsafe Actions. Here's the list of safe actions. So what would a person do to act safely? But what you are asking is equally important, is the structure of dangerous activities, dangerous actions. What would be the motivation and ability of this particular person to do something dangerous, something unsafe? For example, he can easily open a file or just by mistake connect a library which is already outdated. So if you work with people, you'd better think what safe actions you require from them. But for avoiding the critical incidents, you just need to evaluate what motivation the people had and what kind of ability they had to do something dangerous. That's what you need to make sure to avoid that from happening. Any other questions? Yes, a question here. Thank you about explaining this interesting concept to us. As you were speaking to us, I was thinking about different things like HR, the adaptation experts. But would you please respond to this? People as code, you mentioned. If you take people as code, who is supposed to write this code? Good question. And who is supposed to run this code, to write this code and run this code? Who is supposed to write this code? Answering this question, I have bad news and good news to you. Such things that I'm showing you about safe actions and conviction, skills and knowledge, nobody can do that. You mentioned HR, but HR cannot do it for you as experts. But you can take some advice from your colleagues, from the vendors in the industry, and you may find something rare in a very seldom case. These are typical things, basically. Who is supposed to run this code? You can make this people CMDB structure with the existing CMDB. May sound strange, but it's true. The CMDB, which is used to manage your assets, but those fake codes, pseudo codes, can run as part of your integration tasks through the integration buses that already allow you to manage people's skills and integrate it to other processes. So our colleagues and I put this in open source so that we make sure that the developers who work with people and other assets can support us with that. Another question from here, but I'm being prompted that I need to wrap up. Can I just ask for one quick question? No more questions. Okay, I promise you that I will take this question offline. Thanks a lot.